All right, let's get her started, folks. We are on chapter 5 right now. Chapter 5 is about probability. And this is a stack ranks free chapter. It helps a lot when I spell it correctly. Wrap it up. If I can hear you more than I can hear me, then something's off. All right, thank you. Stack ranks free chapter. Fuck, I can't spell.
At least turn about.
I'll have you know I spell normally really well and I write really well. I've earned like over in my full student career, like about $250,000 in scholarships. Scholarships, not like grant money, like Pell Grant, like scholarships. Because I know how to write and I know how to make people happy when I write, make them want to give me money. That's the key to writing a scholarship essay. You gotta make them want to give you their money, which is a fucking art form. Stack, I'm like, yeah, but you wouldn't know it from looking at this fucking screen right now, right? There's no indication I know how to write. We will use the calculator a lot though. So, let's just, we're only doing 5.1 today, which is really just an introduction. Ability. So let's give you the definition. Probability, if I can spell it. Oh my god, I'm apparently in a rush for something. Oh wait, it is Thursday night, tomorrow is a day off, so I get why I'm trying to go faster. Probability is the long-term proportion in which a certain outcome is observed. In situations with short-term uncertainty. Another way of putting it. It's the measure. Of the likelihood. Of a random event. Or phenomenon. Phenomenon, yeah, that looks right. Fucking kinda. Yeah, that's right, phenomenon. Occurring. Does anyone in here never use a deck of cards? Or played like solitaire on the computer? It's okay to say you haven't. It's important if you haven't seen it, I need to know. Cause if everyone knows what a deck of cards is, I'm not gonna go over it. Okay, good. Important things in a deck of cards. We use deck of cards and dice a lot in this class. Probability. Deck of cards has 52 cards. There are 4 suits. Hearts. clubs. That's a club. And then we got our diamonds. And spades. The spades looks like a black heart upside down with a little base on it. Clubs looks like a 3-leaf clover. Hearts and diamonds are red. Each rank. There are 13 ranks. There is ace. 2, 3, 4, 5, 6, 7. That's not a 7, that's a 7. 8, 9, 10. Jack. Queen. And king. Sometimes the ace is listed up here, sometimes ace is a high card. So 4 times 13 is 52. You have a deck. It's gonna be useful to show probability here real quick. Okay, checked. So probability of drawing any given card. There are 52 cards, the probability of drawing the 9 of spades. There is exactly, I'll go over writing that out. Since that's the card I drew at random here. The probability. Of drawing the 9 of spades. We will write it with a P and then parentheses. And then we'll say what we're looking for in the parentheses. Probability 9 of spades. Is 1/52. Which is the number of outcomes. That are 9 of spades. Out of total number of options. 52. So 1 card out of 52. In general, you want to leave probability as a fraction in here. Don't switch it to a decimal. This is an ugly decimal. 1/52 is a simple fraction. Not a lot to remember. The probability of drawing a heart. There's a couple ways of looking at this. There are 13 hearts. Out of 52 cards. Or we could say. There is 1 suit that is hearts. Out of 4 suits. Both of them equal 1/4. So we wanna reduce when we can. How do I reduce 13/52? 52 is 4 times 13. And we cancel out things that are on top and bottom of the numerator, replacing them with ones. And we get 1/4. So let's do a little quick event here, like, let's track. How many hearts, clubs, diamonds, and spades I draw. I'll shuffle these up, I'll draw. I don't know, 12 cards, no. Let's draw 12 cards. Why are you looking at me like that? Oh, looking at me all a little crazy, laughing, giggling. Alright. First one, holy shit,
Oh.
I fucking shuffled these right now and it was near the bottom, like. Alright, so we got one spade. We got one diamond. We got one club. We got another diamond. Got another club. Got another diamond. I'm at 6 more. Heart. Heart. Club. A diamond. A club. A spade. So if we look at this as a frequency thing. Look at this as a frequency of what I do. So this has up to 12 hearts. Frequency is gonna be hearts is 2. Clubs is 4. Diamonds is 4. And spades is 2. And if we convert to relative frequency. There was 12 cards. Write the categories again. This is 2/12. This is 4/12. 4/12. And 2/12. If I reduce these, this is 1/6. 1/3. 1/3. 1/6. So these are short-term outcomes. This is like a short-term. And these are proportions. If things were good. And I was just tracking suits. Perfect world. Or perfect draw. They are each 1/4. I would have gotten 3/12 on each of them. But I didn't. And that's why we say the long-term proportion. I'm gonna define the word in a second, but as the trials. Increase. The short-term proportion. approaches the long-term probability. Now, I'm not gonna draw 400 cards, but I'm gonna show an example of what. Like, let's say I drew 400 cards. And I got hearts. Was 98 out of 400. Clubs was 99 out of 400. Diamonds was 101 out of 400. And spades is 102 out of 400. Very rarely is it exactly spot on. If I do 98 divided by 400 in a calculator, I get 0.245. That is 0.2475. This is 0.2525. And this is 0.255. If I convert the proportion 1/4 to a decimal, it's 0.25. These are closer to 0.25 than 1/3 or 1/6 is. 1/3 is 0.333. And this is, we cut that in half. 0.167. 666, it keeps going like that. So like these are really close, like to 1 decimal, if I rounded, I get, or 2 decimals, if I rounded, I would get 0.25. On this one, if I rounded, I'm nowhere near 0.25. So the more cards you draw, the closer you approach the long-term probability. Or the true probability. So I use the word trial. Trial is conducting an experiment once. And what I just did, draw a single card. Doesn't sound like much of an experiment, but when we're doing statistics and we don't know the outcome, we call it an experiment. So that's one terminology we need. The next one we need is sample space. They usually give the letter S. The sample space is the set of all possible outcomes. For a deck of cards, it's the list of each of the 52 cards. I'm not gonna write out the list of 52 cards, that's batshit crazy.
Thank you.
Sounds like I need to slow the fuck down too. Here at the top of the page, and. Y'all need to let me know if I'm going too fast. Say, slow down, gents. Probably my favorite section. Chapter 5 of the whole damn entire class. I've been paid, while we're waiting for people to write down. I've been paid by casinos to come up with probabilities for rare events. Like if anyone's old enough and has been to a casino, you know, like a progressive jackpot on a slot machine. Well, there's a casino in San Jose that wanted to do progressive jackpots on card tables. So they wanted like a win to happen once every 3 months. And they knew about how many hands were played each week or each day. They did each week. I think they narrowed it down to a month that way. Cause some days are busier than others in a casino, so they figured out how many like hands are played each month. And said, then they gave me that information, they said, all right. Find me a hand in like Texas Hold'em. That with this many hands a month, I would only have to pay out like once every 6 months, once every 3 months. And so coming up with those hands, it was fun. They paid me like $125 an hour to, I did it on Excel. If I'm calculating all probabilities of what we were doing, yeah. $125 an hour to sit on my ass. In my living room on Excel, just typing in shit. I know how probabilities work, so I was just. Doing shit that way, doing number of possible outcomes, dividing by total number of outcomes. And trying to find the sweet spot that gave me the decimal probability that I want. Good math. I think I made overall a good 10,000 off them in the long run. It wasn't easy work, and like they'd have me do it, and then I'd send it to them, and then like the boss would be like, no, I want something different. And so like, okay, you're paying me $125 an hour, that's more than 50 this fucking school pays me. I make 80 something to tutor. Like I went on Saturday when I'm doing tutoring, they pay me $87 an hour to tutor. I guess I can probably make more than that as a salary. Cause I only have to teach. I have like an hour obligation of 20 hours a week, 15 class and 5 office. Alright, so that's it. Nope, I still got writing going on. House kind of distracted.
Sorry.
It's okay. They came back like, I gotta email them, cause it's been about a year. Apparently the process to get shit approved is gotta go, it took like 2 years for them to get it approved with the state. And they'd send it to me and they sent me like last year, they sent me a picture of the. Not flyers, but like giant displays they had on poles of what they were gonna do. And then they had another last minute fucking change they wanted to do. So I made like another $2,000 last year. I gotta see if they're actually running the program now. They told me come out anytime I wanna come out, let me know I'm coming. They'll give me like some chips to play and like let me have steak dinner there. Eat at the casino there, but like it's fucking San Jose, I don't wanna drive out to San Jose. Well, maybe one day. The dude's name is Val too. I forgot about that. And it's a guy. It might be Valentino. I don't know what his name's short for. He went by Val. Which fucking confused the shit out of me, but it was good. He was a fucking cool guy. Alright, so sample space is S. It's a list of all the events or outcome, a list of all the possible outcomes. We call an event. An event is a collection of one or more outcomes. Let me give you examples here. Event. Draw the 9 of spades. Event. Draw a red card. Doesn't have to be exactly one outcome. This one, there's 26 outcomes. That one, there's only one. Jesus, man. Have some class. What is wrong with you? Yeah, I'm entertaining now of myself. Okay. Notice, if you notice, hopefully you notice. Notice that. Relative frequency and probability. Look a lot alike. Like a lot alike. So what's the difference? We calculate them the same way, everything like that. What's the difference between the two? So what we did before, relative frequency. Measures how often. An event occurred. In. Or within. A unit of time. Or number of trials. This is shorthand for number. That's relative frequency. Probability. The likelihood. Of a future. Event. Occurring. That's basically the difference. Past. Future. One is that you've calculated how often it occurred. Probability is the likelihood of it occurring in the future. Try to email Val this weekend and ask him. Ask him if it, not you, the other Val. Ask him if he's seen and started doing it.
Ever get afraid that you're gonna shit yourself when you fart?
I've had moments that I've been afraid that was gonna happen, but not when if I'm afraid that's gonna happen in here, I don't do it in here. I would get up and go to the bathroom, make sure I farted in there. With my pants down. Usually you got a good idea when you're gonna start and not fart. That's a great question. I'm glad it's on a recording.
That's on recording?
Yeah. It's a fucking good question.
What's the probability?
Yeah, I'll have my next question, what's the probability of that?
It's apparently a low probability because it has not happened in 8 years of teaching.
Better, next one's gonna fucking be bad.
Right? Don't want that shit. The question is. Here's the real question, Arturo. If it does happen,
How are you gonna?
am I gonna let you guys know by getting up and racing to the bathroom? Or am I just gonna sit doing it? And then like before I leave, take my jacket off and wrap it around my waist so no one sees the shit stains as I walk down the fucking hall. That's the real fucking question. You could thank Arturo for this conversation. Today's distraction has been brought to you by Arturo. If it's making you sick to your stomach, that's his fault. Thanks, Arturo. That was a good question. I like that problem. So we got some rules for probability. God, I hope that never fucking happens. Cause I don't know how I'll respond. I really don't. If I get up and run out, you'll all know, and then it's gonna be fucking shit pants Jones for the rest of my career. There's gonna be fucking jokes by students for the rest of my career. It'll be fucking 15 years, you guys are long gone, you're fucking. Still, it'll get around,
We'll put it
but do
on,
I really wanna sit in it for an hour? Or 2 hours or 3 hours, fuck, it's disgusting.
I'm gonna put on your rate my professor.
I didn't shit my pants,
Yeah. When it happens, I'm gonna put it.
you go right ahead, then I'm definitely not standing up when it happens. Now I know that you're gonna fucking do. That's cold. Why would you say that? It's one thing to do it, but another thing to tell me, why would you tell me that?
So you don't do it?
It's not something I would voluntarily ever fucking do. It's not something I go, you know what? It's funny our church should ask that, I didn't actually shit myself in class, maybe I should give that a try. What the fuck? It's never going to be a voluntary occurrence. So like threatening to like put it on rate my professor and doing it. That's like threatening to fucking. I don't know. Call the ambulance if I get struck by lightning. Yeah, you're gonna do it, but I'm not struck by lightning, why would you, that's a weird example, but you know what I mean. Alright. So rules of probability. The probability of an event E occurring. We like to use E. And we like to use capital E for it. We call P of E. The probability of event occurring is between 0 and 1. 0 is less than the probability of E, which is less than what? Which means as a fraction. The top. Over the bottom. This is smaller. And this is larger. If it's ever not that way, you done fucked up.
The top will always be smaller.
Yes. That way, if you put it in the calculator, you'll get a decimal that's less than 1.0. And then. That's rule number 1, there's only one other rule. Well, at least for overall probability. The sum of probabilities. The sum of the probabilities for all events. Let's say independent events. Is 1. Sum of the probability of E equals 1. I think I told you this before, that is capital sigma. And it means add the shit up. So add up each probability. Let's just make a quick example here. Let's look at the 4 suits. And face cards versus non-face cards. So the probability of a heart and a face card. There are the Jack of Hearts, the Queen of Hearts, the King of Hearts. There is 3 out of 52. The probability of a heart and not a face card. There are 10 cards. Ace through 10 out of 52. And this is actually the same for each suit, so I can put in each suit and do the same thing and get these same fractions. So I'm gonna do that. My clubs are always look bad when I draw them, so I'm gonna just say club and ace. That covers every single card in the deck. The ones that are 3 out of 52. Are 0.0577 approximately. Which is less than 1. And greater than 0. 10 divided by 52. Those are approximately 0.1923. Which is less than 1 and greater than 0. And since the other ones are 3 and 10, those are fine. They all have the same values. I'm not gonna write that out 8 more times. If I add up all of these. When you add fractions with a common denominator, you add the things on top. So I'm gonna add up all the numerators here. 3 and 10, 3 and 10, 3 and 10, 3 and 10. If I add up all the 3's. That's 12, and I have added up all the 10's, that's 40. And 12 plus 40 is 52. 52 divided by 52 equals 1. This thing here is called a probability model. The probability model shows all outcomes. And their probabilities. Sure, I need to pause for a little bit and let this process. You ready to read all of 4 fucking sentences, Krista? You try to read all of 4 sentences?
Yeah.
Anyone need that up longer? You ready for more? Yeah, okay, I wasn't sure, you put your pen down, so I thought you were done. But I wasn't sure, you looked like you were thinking too, that's why I asked. I read that correctly, we're not ready. This is like cool, I could even give it a few more sentences.
Get beer up,
What?
how long you get beer up?
Until. 7:30 or when everybody leaves, whichever comes first. We're not taking 42 hours today. I'd rather give you guys some time to work on some of this homework and get this probably locked in before we start doing the other shit. So. What is the probability that I draw? mu2, however you spell it. In a deck of cards. A regular deck of cards. Mewtwo is a Pokemon card.
What?
No. There's no Pokemon cards in a regular deck of cards.
Well, they're talking about Pokemon cards, we're talking about Pokemon cards now.
That's why I said out of a regular deck of cards, 0 out of 52, which is 0. The probability of an impossible event. Is 0. What is the probability that I draw? A heart, spade, club. Or diamond? What? It's 52 out of 52 or 1. So the probability of a guaranteed event or certain event. Or 1. What?
Says a space.
I mean, it did fucking say space in a second. Now where the fuck that came from? So we choose to as. Statisticians and mathematicians in the world. We've just decided to say that the probability of an unusual event. This is how we define unusual. Is less than 0.05. Which is 5%. So it's an event that occurs less than 5% of the time. Like David shitting his pants in class. It's an unusual event, it hasn't happened. Hopefully it stays in the impossible event zone. That's in this class, I already know it.
Don't say that, I think this shit.
Where's your refresher?
What?
Where's your refresher you always have?
I didn't have, it was fucking cold outside, it was raining, I grabbed a mocha. And I drank that mocha, I feel pretty good about it. The refresher was like a 30-something ounce, the mocha is only 20. That goes down quick. Especially when it tastes like chocolate. So we've got two methods that we do probability. Two methods to probability. The classical method. Involves. Calculating probabilities. Where the long-term proportion is known. This is when. Every outcome is equally likely. Fuck. Every, there we go, that's how you spell every. Oh my god. Fucking brain's fucking melting down up here. Every outcome is equally likely. The probability of drawing a specific card. Is 1 out of 52. Probability of rolling a specific value. On a 6-sided die. Is 1 out of 6. You can either take a break for 10 minutes, or we can push through and be done in like 15.
That's true.
Push through, does anyone want to opt for the break? Alright, just want to throw that out there. The other method is called the empirical method. Outcomes are not equally likely. Which means. We find the results through experimentation. In this category up here, almost every single casino game should fall in this category. They don't bet on shit, they don't know the outcome. That's not good, that's not good for the casino. The casino is guaranteed in the long run to make a profit on all transactions. They may lose an individual round or a hand. They may have a payout of giant progressive jackpot. That's one event where they pay out a lot. But the rest of the time, they are raking in cash hand over fist by people losing. So in the long run, they have a guaranteed profit.
Do you think the guy Mickey Mantle, who I don't know his last name, he's a really good bettor, do you think he knows like stats like this shit?
Mickey Mantle, like the long deceased, it should be deceased by now.
I don't know about that.
If he's not, he's fucking old as fuck. The Yankee?
Definitely not.
Yankees.
What?
The Yankees.
I said Yankee, didn't I?
Definitely not.
The Yankees.
What?
Yeah, the Yankees.
He's old. A long time ago. Mark Curtis is fucking distracting me here. Alright, so. I'm gonna grab a new piece of paper because. We're gonna talk about something called pass the pigs. I'm gonna show you pigs. I fucking meant to bring them, they're in my office. So instead, I'm gonna show you a picture. Pass the pigs is a fucking pig rolling game. And you're like, what? I don't think the people in my fucking FFA group want me to doing that, or the 4-H club, or what the fuck it's called. Alright. Let me change which stared on the Zoom thing real quick. So pass the pigs. That's a shitty piggy picture. So there's two pigs, you get two pigs, one side has a dot on the pig. This doesn't show very well. I mean, close that shit. There we go, that shows the pigs a little bit better. Pig, one side of the pig has a dot, the other side of the pig doesn't. Their feet are positioned such that, and their ears are slightly different. So that there are 4 ways that it can land. Or 6 ways that it can land. And Wikipedia has the. It shows them, that is called rolling a snouter, where he lands on his nose. So these are. The values. And I am going to, rather than make you write that down, I'm gonna. Go over to the other thing and describe what it means. Let's go back to the camera. So this is what the list of things is either, okay, outcome. Side with dot is up. It happens 0.302 or 30.2% of the time. Side without dot is up 0.349 or 34.9%. A razorback is when they land on their back, so 4 feet are in the air. Happens more often than you would think, 0.224 or 22.4%. A trotter is when they land on their feet. And this happens 0.088 or 8.8% of the time. Snouter is leaning forward on their nose. This happens 0.030 or 3% of the time. And the rarest of all events is the leaning jowler. They are on 1 foot. 1 ear. And nose. They're like leaning forward, tipped on the side of their face. Jowl is your cheek, so it's like they're leaning on their cheek. This happens 0.0061 or 0.61% of the time. Less than 1% of the time. How did they get this? They threw pigs. N equals 11,954 times. So you will actually see problems like this in the homework. Well, where they tell you the probability of something happening, they'll tell you how many events happened. Like how many trials were conducted, and they'll say, how many times did it come up? They will often, in your homework, often N will be some multiple of 10, like 1,000 or 10,000 or 100. The way you calculate, we can calculate how many times something came up. Like, let's say we did probability of side width duct. We know that equals 0.302. It also equals some unknown value, I'm gonna use X, over 11,954. This format here is referred to as N over N of E over N of S. Number of events over number in sample or number in sample space. So like in this case, X is the number of events. If I multiply both sides by 11,954, I get X alone. So X, which is our number of events, is 11,954 times 0.302. And if I round to the nearest whole pig, 3,610. Decide to stop at 11,954. I don't know, it seems like an odd number to stop at, maybe they just got tired of throwing pigs. Was it a good stopping point though? What happens if I throw one more pig? And get another side with top? What's changed in my probability? So the probability of a side with pig. From experimental or empirical calculation. Probably empirical. Empirical might be good. Remember, we're gonna do n of e over n of s. How many are now in e? N of e, how many times has it occurred? $3,611. I just add one to this, right? What about the number in our sample space? We're gonna do the 11,954 plus 1 is 11,955. So 3,611 over 11,955. The 3 decimal places is still 0.302. Probability didn't change. That's what it was before. It didn't change. At some point. Doing more experiments. The effect of a single experiment is in such a low number of decimal places that it stops affecting the probability. This is called the law of large numbers. As n gets larger and larger. The relative frequency. In the empirical method. Approaches the true probability. And when n is large enough. They are equal. To the desired number of decimal places. How is this going to apply and shit like your homework? Almost done, what, like one more line. Homework will say some shit like this. The probability of being left-handed. Is 0.11. If 5,000 people are selected. About how many can we expect to be left-handed? You take the 5,000. You multiply it by 0.11. You get 550. And so they'll give you ones that say exactly 550 or exactly or approximately. You wanna go with 550 approximately. Not exactly. But that's the calculation you need to do, and it's not exact. We'll be near 550. That's some stuff you might see in 5.1. And that's all I got for you today. ETFL, if you got any questions, feel free to stick around. Try to get some practice in on 5.1 before class on Tuesday. Like knowing some bit, like even if you fall behind on chapter 3. Knowing how to do this probability shit for like the basic shit is essential. to Everything we're gonna do for in the rest of the chapter. Okay? Yeah. Oh, great. And then
I was stuck on the same problem.
I don't even remember what I did.
so we can put this and say, open in stat bunch before I do. They give us a lower class limit of 0 and a class limit of 5.
Okay, so
I'm gonna put that. And go,
I should put this.
oh, I did not log in.
It should be.
No, weird. It should be. Ah,
Maybe they're taking it. Well, so-
there we go, okay. So we're gonna go stats, tables, frequency,
You don't have to do the billing, first.
spins are down here. Spin.
So I'm like doing this, sure.
I'm gonna tell it to start at 0. Say width is 0.5. Say compute. Oh shit. You gotta tell it what column to do it on, there's only one, so just click the column. And it gives you these. So. You're not gonna put 0 to 0.5. Because this number and this number have to be different.
That's the number, the one number before, right?
It's one number before. And since they went to 2 decimals here, we're gonna go to 2 decimals there. This one is gonna be 0 to 0.49. And the frequency was 4. And then they ask you to keep going down, and the next one would be 0.5 to 0.99, and whatever was on. Table over here. You're gonna get tired of tabbing back and forth, I would jot those numbers down on a piece of paper.
That's what I've been doing.
In fact, that's a great way to do
Actually,
it, remember to
guys-
write the shit down that you're doing, that way you can look
I
at it
started
later.
taking pictures just today, cause it took me
That's what I was
like a
doing.
day and a half, maybe 2 days to just finish this whole section with 35 questions. I'm like, and then I was looking at ChatGPT, I'm like, 31 questions, and it's like 6 questions and 1 question.
Well, at this point, there's a lot of questions here, but. Now that you know what to do, you can throw in all these super quick, does that make sense? Follow that? Alright.
You know, like that.
Wait,
Let's see.
and then you do your. Worksheet, that's enough, like.
That's a good idea, we should do that.
I look back and I'm just like, and it kind of helps me
Worksheet
for the
right there
next
is key,
question.
but that's what show you right
You
there.
have problems.
We have trouble retaining.
Time
for the windows.
Worksheet,
I love you, utilize it really.
Oh, me
Yeah, I think
too.
mirror that shit.
So I have like, ask a bigger.
Yeah, you just look at it, you literally.
Probably
just-
doesn't.
Let's look up how to